Hello grade 10, here Mr. G with another video of questions. In this case, we are going to be looking at a question on motion in one dimension and more specifically related to graph. Okay, this was a question also from a question paper 2013. This question said a man is running in straight line along a track PQRS. The velocity times graph below represent the motion of the man, and here is the velocity versus times graph. Okay, now the question 1.1 say using all the information on the graph, describe the motion of the man from P to Q, Q to R, and R to S. So let's, before going to the calculations, look at this specific question, which you have to describe the motion of the men in this situation. Okay, so let's divide it in part as the question said. The first one is P to Q. Now P to Q, the object starts from here, in which you can see that the initial velocity is equal to 0. All right, that object starts moving from 0. It goes all the way up until here, that is Q. So this one here in the y-axis is the final velocity, and you can see it is equal to 2 meters per second. Okay, so the man was increasing the velocity from 0 to 2 meters per second. You can see that it's a straight line, and therefore the acceleration is going to be constant. If the line is a straight line, then acceleration is constant, and it took 25 seconds to take or to increase the velocity from 0 to 2 meters per second. That is related to PQ. So we can say that from P to Q, the velocity increases from 0 to 2 meters per second. How long it took? 25 seconds. So the velocity increases from 0 meters per second to 2 meters per second in 25 seconds. And the velocity, or the acceleration, pardon, is constant. So it does this change in velocity with a constant acceleration. Let's go to the second side, or the second part of the track. Now, on this side of the track, now we're working from Q to R. All right, so what we can see, the velocity at Q, which is the initial velocity, was 2 meters per second. It's the same velocity, though the same as the final velocity of PQ. And the velocity at R, if you take it here and you go to the y-axis, you see that it's going to be still 2 meters per second. In other words, velocity stays constant. It is 2 meters per second along the whole track. So velocity is going to be constant. All right, velocity is constant in all that track. Let's take this one here and write it here. Velocity is constant. If velocity is constant, then acceleration is going to be equal to 0. Remember that one. If velocity is constant, it means acceleration is equal to 0. How long it took how long did the man run at this constant velocity? Well, from 25 to 70, and that is equal to 70 minus 25, which is equal to 45 seconds. So that meant move at constant velocity from a Q to R in 45 seconds, or took 45 seconds at that specific velocity. So let's write the answer. So we say here that velocity is constant, QR, velocity is constant and is equal to 2 meters per second. How long it was that? 45 seconds. So the velocity was 2 meters per second for 45 seconds. And the acceleration is 0. That is an important note here. The acceleration is 0. This happens when the velocity is constant. So now, if we go to the last part of the track, which is R to S, we see that the initial velocity of R to S, it was going to be 2 meters per second. Okay, and the object move all the way up until S. Now, what is going to be the final velocity here? We have to go all the way to the y-axis here, and we can see again the velocity is going to be 0. So the final velocity at S is going to be equal to 0 meters per second. All right. How long it took that motion? Well, it's 100 minus 70. It is 100 minus 70, and that is equal to 30 seconds. So the velocity here decreases from 2 to 0 meters per second in 30 seconds. And as well as we said here, in the first part of the motion, the line is straight. We can show us that the acceleration is going to be then constant. Okay, so that, let's write the answer now. Here we see that from R to S, the velocity decreases from 2 meters per second to 0 meters per second. Because it says 0, you don't have to write meters per second, but we can write it if you want, okay, in 30 seconds, and the acceleration is going to be constant. So time was 30 seconds and the acceleration is constant. So this is the first part of the question, where they ask you to describe the motion using words, what happened in those different parts of the track. Okay, now question 1.2. Now they say use the graph and not equation of motion. Note, you cannot use not equation of motion. So you have to answer using the graph without using equation of motion. You have to calculate the acceleration for the last 30 seconds, and you have to calculate the distance covered by the mean in 100 seconds. In other words, the total distance. Okay, so here is the graph. Now, what we need to know? We need to know that in a velocity versus times graph, the acceleration will be equal to the gradient of the graph. Okay, and remember how to calculate gradient. Gradient is equal to change in y divided by change in x. This is how we calculate gradient. It is used in mathematics, so it should not be a big problem to learn how to calculate the gradient. Now, the gradient will give us the acceleration of the object. That is the first important thing here. The gradient will give us, that is the important first thing here, the gradient will give us the acceleration of the object in certain part of the motion. Okay, and the second important thing is to know that the distance, the important thing is that the distance, important thing number two, the distance can be calculated using the area. The area under the graph. The distance can be calculated by the area under the graph. Okay, so that is the second important thing that we are going to use now. The area is different graph. The whole area will be this one here, but we have different figures. So all this here will represent the area. All this one here will represent the area under the graph we are talking about. In this case, for all the entire 100 seconds. So that is all the area under the graph. And you can see here that this area is divided in part. So you divide it here, you have a triangle, you have a right angle for the second side here, and you have a third or a second triangle on this side there. So you have a triangle. Remember, the area of a triangle is equal to half multiplied by base multiplied by height. And in this case, we have the area of a right angle, which is equal to base multiplied by height. So these are important things you need to remember about the graph of velocity versus time. First of all, acceleration will be given by the gradient, or can be calculated using the gradient, and the distance can be calculated by using the area under the graph. So let's now answer the questions. The first question said calculate the acceleration of the object for the last 30 seconds. So this here is 30 seconds. They wanted to calculate the acceleration of that specific side of the question, which is R2S. Okay, now remember, we need the gradient for the acceleration. Gradient for the acceleration. So let's write it down here. Okay, so we know the acceleration is going to be equal to the gradient. This M is for gradient and is equal to change in y divided by change in x. We are for the last 30 seconds. So in this case, here the final y will be this number here, which is 0. This is final y will be equal to 0. And if you go to initial y, is all the way this one, it is going to be 2. So the initial y is equal to 2. Now with the x, the final x will be 100. The initial x will be 70. Alright, so if you substitute that one here in the formula of gradient, we have now that final y is a 0 minus initial y, which is 2, divided by 100 minus 70. That is a very simple calculation, and the answer is going to be a negative 0.07 meters per second squared. So that is the question 2.2.1, where you have to calculate the acceleration using the graph and no equation of motion. Let's go to do question 2.2.2. Now in 2.2 they ask for the distance of the whole motion for the 100 seconds. Okay, so we have to go to calculate the area in each of the different triangles. Okay, so we have, there are 2 triangles and 1 right angle in each of the different figures here. So we have the area of triangle 1, I'm going to call it 1, is equal to half base times height. We have area 2, which is base times height, and we have area 3, which is half base times height. Say that here, this one will be area 1, area 2, area 3. Alright, so for the first one, the base will be this side here, which is 25, and the height will be this one here, which is 2. Alright, so for the first one, it's equal to half multiplied by 25 multiplied by 2, and the answer is going to be 25 meters. Remember, we're calculating area. The unit for area is meter square. Okay, but this one will be equivalent to distance, so later on we leave it in meters. All right, so now here we have the second area is a right angle. So for the right angle, you can see that the base is 70 minus 25, which is this one here. This will be the base, which is equal to 45 seconds in this case, and the height is still 2. So here we're going to take off the unit there. This is equal to base, which is 45 multiplied by the height, which is 2, and the answer is 90. And for the last triangle, here in the graph you have the base, which is 30, the height, which is 2. So it's half of the product of 30 times 2, and that will give us 30. So now what is the distance? The distance will be equal to the total area and will be equal to 25 plus 90 plus 30. And the answer of this one is going to be 145 meters. This is the final answer for the total distance covered by the man. So this is the whole question. I hope it helped. It's not that difficult. There are very important things that you must remember. One of them is this one, acceleration is equivalent to gradient. This part here is important, and the second part is this one of distance and area. Okay, I hope this helped. If it did help you, then a thumb up. I will make next video related to another topic for the test, and good luck with the upcoming exams. See you next time.